So our channel has been running for a bit, but if you take a look at it, you might see something weird, and that is that we have some depths and overtopping in places where we shouldn't, and that's because we haven't put our culverts in yet. So let's go ahead and stop the run so we can go put our culverts in. Should just go to the next time step and then it'll finish. This data is useless since we don't have our culverts in there. So we'll close it and let's go put our culverts in. So our culverts are going to go, this is the upstream culvert. So we need to swap over to the structure editor, add a structure, and then we need to start our structure in the left bank of the upstream channel and end it in the left bank of the downstream channel. So you'll click, left click, right click, and click OK. Then we'll just move downstream and go grab the next one. And again, I'm just moving downstream, I'm just panning using the center wheel. Left click, right click, and click OK. Not sure why my cursor's not turning into an editing cursor, but whatever. Then we come back here and we click Save, and then we can start to name our structures and fill out the data. So let's go to structure 1 and click this guy and go to structure 1. And let's name this Greenway 1. It needs to be this exact spelling and capitalization. It is a channel-to-channel structure from this, because this side is a channel and this side is a channel. And it is a rating table. And then we'll go to the next one. Same thing. Greenway 2. And it is also a channel-to-channel structure, meaning that this side of the structure is a channel and this side of the structure is a channel. Has a rating table. And now we need to import the rating tables, or you can just develop them in this table. But I'm going to import them because I have two files right here ready to go. See the name? Greenway 1 and Greenway 2. That's important. That needs to match these guys. So click OK. It says only files with the correct file name will be loaded. That's what that message said. Click OK, and it says that the following files were loaded. Click OK one more time, and what happens is that your table is updated for each individual structure that you load. And that's it. That's as easy as it gets for channels. Of course, you do need to create that rating table data, or you can put these in using the generalized culvert equation. These had a rating table from HY8. The rating table was developed using HY8, or we could put these in using the generalized culvert equation. Either way works fine. And let's talk about the other controls of this data. Let's go ahead and zoom in on this, and let's talk about this tailwater control. So there's 3 switch positions here. The first switch position is no tailwater effect. The discharge is only based on the headwater, and there's no submergence control, there's no reduced discharge, and there's no upstream flow allowed. So this is like a structure that has 0 tailwater control and no upstream flow allowed, so like a flap gate maybe. This switch is the submergence is applied, meaning that the tailwater can dampen what's moving through the structure. So reduce discharge using the submergence control, but no upstream flow allowed, meaning flap gate. And this third one is to reduce the discharge but allow for reverse flow if possible. So if we leave all these to no tailwater control, we'll actually get a message when we run the model that one of them should probably set to tailwater control. Now there is a drop structure at the end of this, so when you set this up in HY8, you do want to make it a bit more complex to account for that. Let's go down to the stream to the next one. And note that one thing that is important here is that you do capture your transitions away from and leading up to these structures, and you saw that when we put our cross sections in, we did indeed capture those transitions. Okay, so that's important. Again, no tailwater effect. We'll just leave it off and see what the model tells us is wrong with it. Head reference elevation, I am going to leave this to 0 unless as the water moves downstream and hits that head reference elevation or hits that structure, if there was a weir in here, So the water would have to get up to a different elevation than the invert of the channel before it started to flow through the structure. In other words, a weir and then a drop structure on the other side. That is where you would put in the reference elevation for the headwater. We don't need a conduit length or geometry because we are using a rating table. If you were using the generalized culvert equation, you would fill in these two variables. And we are now ready to run the schematize button because our structures are complete. And so you now see that we have converted our user layer to a schema layer. The user layer is green. It doesn't have to be, as long as it's inside the grid element, it's going to be positioned correctly. The schema layer is blue and it's perfectly aligned to the center of the grid element, meaning that just like when you export this data, it's going to look like this will be assigned to these two grid elements. Let's go ahead and export the data right now and take a look at the data that we export, and then we'll run the model again. And if you haven't figured this out by now, oh wait, sorry, let's turn on the control parameter for our structures, turn that on, and set that to save, and then export it. Export the DAT files. We can put it back in the same folder, but again, let's go in here into that folder and just delete that data because we don't need it, and we'll export it. And let's take a look at the two files that we changed. So we changed these two files this time. So I'll right click, open in Notepad++. You now see here that we have a new variable, a switch that says we need to use culverts. And you see here in the highstruct.dat we have two structures. S means a new structure. T means that this structure is using a rating table, and the rating table has, well, we'll talk about that in a second. This is the name of the structure. Please don't use any spaces. It needs to be all one word, no spaces. This means it's using a rating table. 0, let's see, 0 means it's using a culvert equation, or no, sorry, 0 means it's using like a weir equation or something. 1 means it's using a rating table. 2 means it's using a generalized culvert equation. And I can't remember if there's any other switches. This one is the channel to channel. So 0 is floodplain to floodplain, 1 is channel to channel, 2 is floodplain to channel, and 3 is channel to floodplain, something like that. Inlet grid element number, outlet grid element number, tailwater switch, head reference elevation, culvert length, and culvert diameter for the generalized culvert equation. Rating table. T means a new record or a new line of data. They always need to start at 0. This is depth at the inlet. This is discharge through the structure. This is an area, which we typically don't use unless the culvert gets really long, like over 500 feet long. Then we start using this data. But that's an advanced topic, so I'm not going to talk about it right now. Again, back in your data input manual, if you go to highstruct.dat, you can see all of these variable names for these different lines of data. See, this is line 1, S, structure name, if it's a floodplain or channel, if it's a curve or a table, the inload, the outnode, the tailwater condition, head reference elevation, channel length, channel diameter, I'm sorry, culvert length, culvert diameter. And then down here we are on the F lines to represent the table. Nope, I lied. Apologize, I'm on the wrong one. Sorry. I'm still on the wrong one. Sorry. We are on line 4, which is a T line. That's this guy. H is the depth at the inlet, or if you have your submersion control turned on. So we don't. So this is the depth of the inlet, the discharge through the structure, and then we, of course, are not using the A table. And then of course you want to learn about those variables, and this is just a sample of the data. Some of the notes and individual parameters, what kind of number they are, range. I mean, obviously you're not going to write a table to infinity, right? What you're going to do is take it up to, and I don't even know why this goes up to 20 feet, because the channel itself is only like 10 to 12 feet deep. So there's no way that this is going to go up to 20 feet in water surface in depth at the inlet of that structure. So this is a bit overkill in that regard. So you need to go up to the highest depth that you think that structure can hold and then limit it to that depth. You don't have to go further than that. But if you don't go up far enough, you will be reducing the discharge through your structure to that last discharge that you had for that specific depth. You do need more data down here on the curve of the data, that this curve is not as linear as this curve right here, so you do need more data down in this area. And because it will be doing a linear interpolation between these data points. So you don't want to go from 0 to 1,000 CFS over one single data point, because it'll be a linear interpolation. You might get too much data. So that's it. Let's just run it. And so we go run flow 2D. And again, we're just going to wait for it to start because it's doing its checks. It's checking to make sure you set the data up correctly. And I kind of cut myself off mid-thought when I started this last run, but what I wanted to say is you might notice that we are building this project in a specific sequence. Okay, we build a feature, then we run a test, then we build a feature, then another feature, then we run another test. We're doing that intentionally. Now you can see our 500, our stepped discharge coming down through here and filling up our channel in addition to whatever rain is raining on the channel. So when this simulation ends, we can go into it and look and see how our water is filling the channel. Now you can see our rainfall is coming up. Oh, I know why we're getting rainfall so early in that channel, because we don't have infiltration turned on, because it's a concrete channel. Okay, that makes sense. So you can see what's going to happen here is that the rain is going to be this cyan color, and then this royal blue color is going to be our inflow hydrograph on our floodplain. So it's going to go up and just like this and then come down like that. That'll be our floodplain hydrograph. Our channel hydrograph is going to go up in steps. It's going to go it's going to start at 100, and then it's going to go up to 50, and then it's going to go up to 550, and then once it gets to 550 or 450, it's going to keep going. But I think this is the floodplain hydrograph that's being plotted right here. And you can tell that by, in the inflow.dat file, you can tell that by this number right here. So this is the floodplain hydrograph, and that is the one that's being plotted. So we'll just let this run and minimize this and turn the video off because the structures are complete.